Hello everyone, I am Soham and this is Perfect Shield. Right now, there is a fatal flaw in Web3 AI agents. They are great at chatting but blind when trading. If you tell an AI with a hardware wallet to buy a trending token, it will blindly sign the transaction, even if it's a honeypot. To fix this, I have built an OS level execution interceptor. I have deployed it directly to a live Pivot style instance and the agent is live on Telegram. So let us just open in Telegram and initialize the shield in strict mode to lock down the hardware wallet. So we have started the bot and it is saying that hello again, I'm ready to assist you. Since I had already tested you, it is currently active in strict mode and let me just start with the command which we want to test because I have already initialized and set it to strict mode. So the first command is already done. Let us just send this one and let me tell you the purpose of this command. Like we are telling the AI to buy a known honeypot. Normally the agent would formulate the payload and lose the funds, but Perfect Shield intercepts the intent. It queries the Go Plus Oracle in real time, detects the 100% buy text and dev reclaimable ownership, and categorically aborts the transaction before the T hardware is ever touched. You can even see this message. I must abort this transaction. It has detected that this token is malicious and therefore the transaction has been blocked. And it is also telling me the reasons. Now let us go to the next command. And what we're doing here is, like the contract is safe, but the liquidity was pulled. We simulate a safe token like cake. The shield runs a live RPC simulation directly on the BNB smart chain to prove the root is valid. It dynamically calculates the auto slippage, returns the exact expected output, and only then verifies the payload as safe for T2 sign. We can see the message. The simulation was successful, and it test verified that contract is safe. It is giving me a target contract, expected output, and it is also giving me the auto slippage used. And the result was it was safely mock signed using the T environment. And like before deploying it to the cloud, like this is testing on the actual Pivers with Pivers bot, but before deploying it to the cloud, I built and tested the entire architecture locally as well, where you can see all of the commands and how I initialized it. We can see in the terminal lab. Like it is hard Web3 infrastructure built directly from the scratch. We're just handling the local CLI state, stateful security bootstrapping. We have live ethers.js routing and mock hardware signatures. So this was the live demo which I showed you for Perfect Shield. And now in the next part of this video, I'll show you the previous demo video I created, which has the terminal outputs and all. So thank you for this. And now let us shift to the terminal side. Hello everyone, my name is Soham and this is Perfect Shield. Right now, there is a massive flaw in Web3 AI agents. They are great at chatting but blind when trading. If you tell an AI with a TWE hardware wallet to buy a trending token, it will blindly sign the transaction, even if it's a honeypot. I have built an OS level interceptor to stop this. Keep in mind, this is an OS level interceptor. Let us start with the first command, which is node index.js setup. And here, like because we are dealing with autonomous agents moving real funds, explicit user consent is paramount. If an agent tries to trade without configuring the shield, it gets blocked. We build an interactive bootstrap wizard that saves the agent's state locally. Let us type one for the strict mode because users can choose warning mode to just get alerts and strict mode which revokes the AI's ability to sign malicious contracts at the OS level. We are running it currently at the strict mode. Let us move to the second feature with the help of the second command we have here. And let us see what happens when the agent attempts to buy a known honeypot. Before the hardware wallet is even touched, the shield intercepts the payload. It queries the Go Plus security oracle in real time. We can see with the output that the red text appears and it detects that 100% buy text and dev reclaimable ownership and categorically aborts the transaction. The T signature is blocked and the agent's funds are safe. Now let us go to the feature third and fourth together with the help of last command we have here. Keep in mind that these are all example commands and we can test any contract with it. You can test yourself, get some contract address and check it. So let us go with this command. And what if the contract code is safe, but the liquidity was just pulled? Standard scanners miss this. Let us run a safe token, like this is the code for pancake swaps cake. And we can see that the green text appears. Like here is where the shield outwits basic scanners. After verifying the code, it runs a live RPC simulation directly on the BNB smart chain to prove the root is valid, returning the exact expected output. If the pool is drained, the simulation reverts and saves the guess. Also, I can see the auto slippage here. Like it handles UX as well. It dynamically reads the exact text from the contract and calculates auto slippage, ensuring the agent's trade never fail due to parameter errors. So these were the features we had in this app. And once all three checks are clear, that is code security, root simulation, and parameter math, we can see that the verified payload is safely passed to the perfect claw T for signing. Perfect Shield is live right now on the Piver store. Thank you for listening.